Good morning. There's a little bit of delay this week. I have been very busy. There's many gatherings, and that's why I couldn't reply you guys' email that quick this week. It's getting closer to the Chinese New Year, and it's been crazy meeting everyone. It will be more. There will be more and more dinners and coming up. I hope that I can finish up those videos as soon as possible. But if there's a little bit delay, please apologize for it. That may happen. So for this one, you can see this further clip 004, and we move on to look at a concept called normal distributions. So it's about something that distribute. Distributions, last times, and we look at these terms a lot, we call them spread. We have done some something called standard deviations. As a standard deviation is a measurement of how those numbers are spread around. And you can see sometimes numbers can be kind of pack up very close, a cluster very close to the smaller values, or some other, or the opposite. So you may have more data getting closer to the higher values. So when we have those, the standard deviations is teaching us how, is basically showing us how those numbers spread, and the center, or plus the center of the data, it gives us a bit more information of the data collected. And we can imagine sometimes you may find that sometimes the graph may be spreading at different patterns. Some of them may have more data tend to on the one side, the other tend to on the other side, or they just like randomly distributed, so like you can't even find the patterns at all. But there's one distribution that's all around the world that going to use or going to see a lot. We call these normal distributions. That looks like the data tends to have the center value right in the middle, and then gradually come down on each side. So if you try to say that a histogram, so let's say from 0 to 100 marks for exam score, you'll find that there are more people kind of like right down in the middle. So like 50, like score 50, you have quite a lot of people, and gradually you have less and less people getting higher marks, and you expect that there would be not a lot to get 100 marks, and then you have roughly the same kind of like a mirror image on the other side, gradually decreasing along the side like this. And these particular distributions, we call them normal distributions. It's like we expected most of the time, if things that randomly dropped or collected, the values, the center values, should be somehow right at the middle, in the middle of the range. So range is between 0 and 100. Right in the middle would be 50. So we call this one, this no bias on each side. So you can see that first thing, there would be a center values closer to the middle. And then you'll find that the trends getting on each side basically is roughly the same. There's no bias on each side. If we encounter this type of distribution, which is a lot happening around the world, and we call them normal distributions. And the normal distribution have another name. People always call this a bell curve. So a bell curve is not hard to understand. A bell just like a bell. And you may ask me about what kind of distributions or what kind of data we look at will kind of like contribute will make a bell shape. There's a lot of examples. One of the example you do, the heights of people, or any other thing like the size of the chickens, or the weight or the weight of the the weight of a tiger or a crocodile. All these kind of like measurements would be can be basically draw a graph more like a bell curve. And then you may try to also looking at more internal measurements, the physiological measurements like the blood pressures. And then some people will find that something more related to mentals, your IQ score. The IQ score can be like a normal distributed. There's the majority of the people heading right in the middle, and then the people gradually decrease on each side, gradually decrease on the other side. So those would be lots of that. All this type would be many studies that we look at, and we find that bell curve has a very important part for us to understand our world. So therefore, for the rest of the class, we will try to look at bell curve together. So when you try to have a bell curve, I like to show you one of the documents I find the documents not details enough in the book, so I basically have you some additional informations. It's also in the Dropbox. So if you find the Dropbox, there will be a file names called Normal Distribution Notes. I'd like you to go through it yourself. And first, I'd like you to look at is this bell curve. If I just crop a pictures here, maybe just don't need this one anymore. Crop this one. A bell curve can be looked at, drop it down in like 50-50. So if we look at this as a 50-50 graph, and then right in the middle, you can basically chop this graph in half. There would be a half from the lowest, the minimum, all the way to the midpoint, and then to the maximum. For the first 50%, it would be the first half of the bell shape, and then you have the second 50% would be the second half. So we have the first half, the second half. And what would be the value we expected for all bell curve? We'll find that from a minimum point all the way to the mean or to the average. That would be the first 50% and then the second 50%. And according to kind of like what we discussed before, we say that for the distribution graph, for this normal distribution, you will find that right in the middle will be the center values, and we have the most number of entries that related to the center. And because mole basically means the most frequent, like most frequent numbers or most frequent data entries, then we also expect that right at the midpoint there would be our mode. If you put the number from the smallest to the biggest, right in the middle will be medians. So one fun fact, the M, the mean, the median, and the mode can also be found at this point, the top of the bell curve. So the top of the bell curve tells you the center, and the center measurement, no matter it's mean or median or mode, they all refer to that point. And the percentage is the most important part that we want to focus on bell curve. So if there's a mirror image, the left-hand side here and the right-hand side there will have exactly the same percentage. And they are 50 and 50%, which is halfway. Then you will ask me another question. What happens if you chop this in half? Let's say from here, mean to here, we've got a quarter. And then here, we've got a 3/4. If I try to put a line here and then put another line there, would that be 25%? Try to look at this yourself. From minimum all the way to a quarter, compared to a quarter all the way to the 50%, the median here. The shape or the area, that one has way more than the little area there down here. So you would expect from the first quarter, there's not 25%. So the only thing that you remember is just 50-50 first. So we can't just look at like a quarter of the value, then it's 25% of the data. We have some other way to look at that. And you can see very clearly, this one definitely more than 25%, way more. And this tiny area there is way less than 25%. So we can't use a quarter of the data or the quartile to determine the percentage, while we have a more fancy way to look at that. The fancy way look at that come into a term that are SD, standard deviations. So is the standard deviations control the percentage, not the Q1 or Q3 that we find in the box plot. Standard deviations has a particular symbols for it, like this circle with a line there, or people sometimes just say S or SD. So those are referring exactly the same thing. So we go back to the bell curve. So if we have a bell curve, hopefully, looks pretty good. Somewhere here is the midpoint. We've got the highest. And here is the mean. So mean, most of the time we call that with a straight line at the top, we call it the mean, X with a line on top of it. And because when you move backward to the left-hand side, the value is basically getting smaller. If you move forward, the value is getting bigger. So if you say moving forward, this side here would be a mean plus getting bigger. On the other side, the left-hand side there, it would make sense that is the mean. Take away some number. Yes? And the bell curve, as we kind of discussed, is controlled by the standard deviations. So we can basically say that we like to look at how many deviations you're going to plus on the graph, and then how many deviations you're going to minus on the graph. It's easy to basically to remember these particular values. It's not many that we need to remember. You basically walk 3 steps forward and 3 steps backward, the max. You can't do any more. So 1 step, 2 steps, 3 steps. Go backward. 1 step, 2 steps, 3 steps. When you move on forward, right-hand side, you're getting more and more standard deviations. You have 1 standard deviation plus the mean, or the mean plus 2 standard deviation, and the mean plus 3 standard deviations. So we basically put the standard deviations there. 1 gap, 2 gaps, 3. Then exactly the same, instead of plus, you take away 1 standard deviations, you take away 2 standard deviations, and you take away 3 standard deviations. So if you are able to remember this one just on the graph on the screen there, and we've done more than half of the bell curve, because yeah, we put down how many sections there, chop down right in the middle, then we have 1, 2, 3 sections, and then you have 1, 2, 3 sections. So there's 1, 2, 3, 4, 5, 6. There's 6 regions that we need to study. You don't need to remember it because it's always in the notebook, and I recommend that you drop in your cheat sheet and whatever notebook that you're making for your exam, and you can always refer back to it. The percentage is not that important, but it's the way that you kind of you can find out the information is important and understand what is going on. When next time when I ask you about a bell curve, you don't say, oh, you don't give me a histogram, you should draw me this, right? So the reason I used my note, give you the note, because it's more details saying each one of them. So if we try to look at that, the rules for normal distributions is 68, 95, and 99.7%. Okay, so one more time, hopefully remember it. I'll give you 10 seconds. 68, 95, 99.7. So what is the rule that we try to do for all the bell curve? Is 68%, 95%, and 99.7%. Those 3 numbers, right? So what do you mean by that? So if I highlight them into the graph that I have here, it looks better. So if I use yellow, represent 68%. We are trying to look at the mean minus 1 standard deviations all the way to the mean, and then to the mean to 1 more of the standard deviations. This particular region, the yellow part. Yes? Make sense? Then I'll use the green one there, represent 95. Oh no, not the green, colorblind. It's the blue. The blue is from this point, you take away 2 standard deviation all the way to take away 1, and keep going to 0, and then keep going to 1, and then 2. So the 95% is represent the regions all the way blah, 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 blah. And you can see that the one that green in the middle would be the overlap area. Okay, and the last one would be the 97. I'll just highlight it. The 97% would be highlighted all the way from -3 to +3. The regions that I used the red pen to highlight. Can you see that? My graph is terrible, but you always have your notes to refer back. So what does that mean is, if you have a bell curve, the 68% out of all the entries, so if you have 100 survey, 68 survey would be between from the -1 to the mean, then to the +1 standard deviations. Is the measurement is basically start from the mean, and you try to measure the one that left hand side and the right hand side. Then you have the 2 standard deviation for 95%. 95% of all the entries, the values, would be able to find in between from the -2 standard deviation all the way to +2 standard deviations. Then 3 standard deviations would be 99.7%. 99.7%. And this basically, if you try to look at that, or what if you still have like the tiny bit on each side? So what is the tiny bit on each side? It would be 0.3%. So for 1,000 survey, you're talking about 3 out of 1,000. 3 out of 1,000 would be talking about beyond 99.7. So when you say that in the exam score, people getting 99.99, what does that mean? It just means that they belong to beyond 3 standard deviation range, which is the odd one out. We don't like it. So for statistics, all you need to remember is just 1, 2, and 3. Forget about anything beyond 3, right? So if that's so if you kind of like happy with those concepts, then we can try to find out what's going on to look at those graphs. So if I give you 2 graphs, one's this, very flat, the other one there is flat and then tall and then jump up down there. Both of them are bell curve because it's symmetry. Yes? Make sense? Then what do I want you to find out is tell me about what happened to the standard deviations between them. Which one do you think would have a bigger standard deviations? So if those values from 0 to 100 there, and here is from 0 to 100 there. What do we say? If we think that both of them bell curve, then we can say we move 1 step, 2 steps, 3 steps. Right here would be the border, and then we go back 1, 2, 3. That one would be another border, and here would be 1 standard deviation, 2, and 3 standard deviations. So each of the standard deviation is roughly from here to there, right? Make sense? If you try to look at the other graph, 1, 2, 3 steps, you basically reach the region. And on the other hand, 1, 2, 3, you reach the border. Then you will find this particular one there would have this gap refers to the standard deviations. Compared to the red and the blue one, which one has the biggest standard deviation? You'll find that the red one there would be bigger standard deviations. And the blue one would have smaller standard deviations. Yes? Makes sense? And both of them have exactly the same mean right in the middle, 50. 50. The differences for them is the standard deviations. So what if I have another graph saying this one here and the other one saying this one there? Then you'll find that the first one, you can see the standard deviation would be smaller compared the next one, straightforward, because more spread around, and then the standard deviation would be bigger. The one that very close to each other, the standard deviation would be smaller. However, you'll find that right in the midpoint, so if you start from 0 to 100 for your graph, this is 0 and this is 100 for your graph. The one that right in the middle, say that this is 50, and here the mean would be 25, compares with this one is right in the middle, 50. For graph. So if you're looking at those 4 graphs, you can tell, you can basically tell some Some graph may have the same mean, but different standard deviations. Some graph may have the same standard deviations with different mean. Some graph would be different mean and different standard deviations. And we need to be able to tell the differences and try to compare between them. Yes? So what we do, if I ask you to do one thing, so plot two graphs, you should be able to do it with me. For me, so I say the score of a particular class. The mean of a class A is 60 marks, 60%. Well, with the standard deviation for them is 5%. This is the first graph. And then the second graph you can try to do would be the other class. The mean for them would be slightly lower, 56%, but they will have a much bigger standard deviations. How would you do? How would you approach this particular graph? For the first one, we need to have a graph and determine the three standard deviations. Because the one that, let's say this is from 0 to 100, 60 is somewhere here. And here 60 would be the highest point. One step, 65. 2 steps, 70. 3 steps, 75. Go back, 55, 50, and 45. And your graph basically starts from 45 and ends with 75. And you sort of like draw a bell curve there and extend a little bit on each side. See? Done. The next one, what would be look like? Compare those two graphs. Try to you start from 55, basically slightly less than 60, but the standard deviation is 12%. So 50, 12% from, give me a bit more room, from 56 here, 12% would be 68. So here would be 68. 12% would be 70, 80. And then another 12% would be 92. One gap, two gaps, three gaps. Going back, one gap, two gaps, three gaps. 56 take away 12 will have 44. 44 take away 12, 32. 32 take away 12 would be 20. And our graph will start from here, top here, and down there. So imagine the class for class A and B is roughly the same numbers. Then you have a bit more sharp curve and narrow for the first one, but the mean is a bit bigger. And you have a more kind of a flat one spread around. And then you have the mean is at 56. People can just look at the graph and tell which class kind of better. So you can say the class A for that particular test performs a bit better, and the standard among the class is pretty constant among each other. It's a very competitive class. While B would be more spread around. You've got extremely good students, IQ with like more than 130. Then you have like basically skipping the class and not doing anything, and basically give you the blank sheet when they're in the exam. You have the two extreme in the class. So for the class B, and as I approach, then you may think about, what can we do with each class? Do you need to change the way that you teach? Things like that, right? So hopefully that one not very difficult for you. Then the next one I like to do before we finish in half an hour, we call them standard score or set score. is highly related to bell curve because we know that most of the range, most of the data will fall into +3 and -3 standard deviations right in the middle. So the data that we have is between +3 and -3. And the standard score based on how many standard deviation is it away from the mean instead of the actual marks. So going back to the questions at the class A and class B. What in the class A, if let's say Tom, okay, Tom score somewhere 66% in the course. So in the 66% compare with class B, we have someone else. We have Dom. Also scores 66%. Compared to both of them, class A and class B, is Tom's performance be better? Then is Dom perform a little bit better? Even though both of them are 66%. We cannot put Dom into class A and do the test again, but we do able to use set score, standard score to tell kind of the difference between them. So what do we do is to calculate Tom is 66%, which is how many percentage away from the mean. The mean for the class A is 60%. So 66% take away 60 equals to 6%. Is 6% more than the mean. And we need to consider what would be the standard deviation. As the standard deviation is equals to 5%, then I want to ask myself how many standard deviations away from the mean. Which is 6% divided by 5, because like each standard deviation is 5, is 1.2. That is the answer. And the set score would be 1.3. So we call this set score. We also call this standardized score. So everything when we go in your exam score, you say things get scaled up and things get scaled down, and this based on the set score. So for the set score is 1.2 for Tom. So how about class B, Dom? Dom also scores 66%, but the mean for that test. So just imagine class A and class B are completely different school, and they never interact, and they do different tests. The test is not exactly the same. Then we just try to find out, okay, based on that, what do we do? Then the mean for the second class is 56. And is equals to 66% take away 56, and we've got 10%. And how many standard deviation away from the mean? So the standard deviation is 12%. Standard deviation equals to 12%. Then what is the set score? The set score is equals to the differences take away, well, not take away, over the standard deviation percentage. This times 10 over 12, which is can't do it. 10 over 12 give us 0.83. Set score. So now we can tell which one is actually a little bit better. Tom is a little better, even though even though both of them score 66%. Yes, it's just saying that, yeah, the second class have a harder test. Yeah, the first one has I can't tell which one is the harder test, but Tom and Dom can be using the set score to compare, and Tom is 1.2 away from the mean, and Dom is not even 0.83. So where is Tom for the first graph? Tom is 62 somewhere here, and Dom is somewhere there. It's, in terms of the graph, it's more away. Tom is more away from the standard deviations, and Dom is closer to the standard deviations, right? So I hope it makes sense to you, and it's about another 30 minutes. So I will give you more questions to do. If you can start doing those guided questions, it would be good. I will try to finish another 2 videos as soon as possible. Then I will be back. Okay, guys. Thank you. Bye bye.